Today, let's compare ratios using ratio tables. Alright, first, for a review, let's create 4 equivalent ratios. I want 2 of those 4 equivalent ratios to be scaled up, and 2 of the equivalent ratios to be scaled down. And we're going to use the base ratio of 30 to 80. So once again, create 4 equivalent ratios, 2 of them by scaling up and 2 of them by scaling down, using the ratio 30 to 80. The first 2 ratios are going to be scaled up. So let's take a look at our original 30 to 80. And scaling up simply means we want to have, 2 times as many, 3 times as many, 4 times, whatever, how many times you want to scale this guy up. For sake of illustration, I'm just going to scale it up double. So we're going to have 2 times as much. And since we doubled the original ratio, we now know an equivalent ratio would be 60 to 160. We could also find another equivalent ratio by tripling that original ratio, and we will have 90 to 240. Okay, remember the second half of the problem was to scale down and find 2 equivalent ratios that way. So I could scale down by cutting it in half, and I'll have a 15 to 40 ratio, which is now equivalent to that 30 to 80. And then this time, instead of using our original ratio, I'm just going to use the ratio that I currently have because it's equivalent to 30 to 80. And I'm going to take this ratio of 15 to 40 and I'm going to cut it into fifths, or I'm going to divide each part by 5. And because I've done the same to both sides, I have an equivalent ratio of 3 to 8. Okay, take a look at this table. It's showing us the time spent in a pizzeria by hours, and in the column on the right, tells us how many pizzas are sold in those hours. I'd like you to take a moment and write a ratio to describe the relationship that's shown in this table. Well, we could start anywhere we'd like with this table, but I'm going to start with the first set of values. The 2 hours gives us 16 pizzas. That's a ratio of 2 to 16. And because we know that ratios have value in the form of a fraction, I can take 2 to 16, and I know its value in fraction form is 2/16. And because I know how to deal with fractions, I know that if I do something to both sides, the numerator and the denominator of the fraction, it will be equivalent. So I'm going to divide both by a number that I see 2. I know that both of these can be divided by 2, so I'll do that. So the numerator now being 1, because 2 divided by 2 is 1. Let's work on the denominator. 16 divided by 2 is 8, giving us a fraction now of 1/8. And because we know that ratios work both ways, that a ratio has a value that is a fraction form, we also know that a fraction is also a ratio if we turn it back to ratio form. So 1/8 is the equivalent ratio of 1 to 8. And because I cannot simplify this anymore, this is the ratio for the entire table. Whether I'm dealing with 10 hours and getting 80 pizzas or 5 hours and getting 40 pizzas, the ratio is 1 to 8. Let's talk about now how fast certain people can text. Okay, so we have 3 girls, Michaela, Jenna, and Maria, and each girl has their own table, and this tells us how fast they can text per certain amount of minutes. For instance, take a look at Jenna. For every 4 minutes, Jenna can text 180 words. Our job is to find out who is the fastest texter out of these 3 girls. How are we going to do that? So one thing we could do is look for a certain amount of time that all 3 girls were tested for texting. And if I look at the shortest amount of time that they were tested, let's see, Michaela had 3 minutes, Jenna had 2, and Maria 3. That doesn't help me because they are not all 3 and they're not all 2. And if I look at the longest amount of time that they were tested, let's see, Michaela 9 minutes, Jenna 8, Maria 12. Well, that doesn't help me either, because what I need is for all 3 girls to be tested for the same amount of time in order for me to simply look and say, oh yeah, this girl was able to text the most amount of words. So I'm just going to go around and look for numbers that are the same amount of minutes. So Michaela did 3, Maria did 3, but Jenna didn't, so that doesn't help. Let's see, Maria did 9 minutes, Michaela did 9 minutes. Nope, Jenna didn't do 9 minutes. And so because I don't see an amount of time that's the same for all 3 girls, I'm going to have to extend this table and come up with some value that is the same for all 3 girls. What is a number or an amount of time that I could put in this table that would make it nice and easy for us to work with? Well, 1 minute would make it super easy, because if I can look at how much Michaela texted in 1 minute and Jenna and Maria texted in 1 minute, it'd be easy for me to see who texted the most. But how am I going to do that? How am I going to know how many words Michaela tested out in 1 minute if she didn't actually test at 1 minute? Well, because there is a ratio shown in all the other values, I can use that ratio to find out how many words she would have texted in 1 minute. So, how do we go from 3 minutes to 1 minute? Well, if I have 3 minutes, then 1 minute is 3 times smaller than that. Or taking 3 minutes, I can break it into groups of 3 and I'll have 1 minute. So 3 divided by 3. And of course, if we are working with equivalent ratios, which we must be working with, then I'll need to do the same to the amount of words. I'm going to put it into 3 groups. 150 into 3 will give me 50 words. And there we go. Michaela, when and if she texts for 1 minute and it follows that ratio, then she will have texted 50 words. Hey, this is a good start. And so let's do the same now with Jenna. We know that she tested for 2 minutes, and we're going to pretend that she tests at 1. How do we go from 2 to 1? Well, the value jump there is that it's 2 minutes divided by 2. That will give us 1. So we're going to need to do that to the top and bottom. And so 90 now, split also into 2 groups, will give us 45. Hey, and this is great because now I know that for Jenna's 1 minute, she can text 45 words. And for Michaela's 1 minute, she can text 50 words. And so we already know that Michaela is a faster texter than Jenna. I'm going to leave Maria open, and I want you to come up with the amount of words that Maria would text in 1 minute. So I'm hoping that you came up with 40. Why? Well, to go from 3 minutes to 1 minute on Maria's table, we'd have to divide 3 by 3. And if it's an equivalent ratio, which it must be, then we must also divide her 120 words by 3 and come up with 40. Hey, and this totally helps us out now, because now we can look at all 3 girls tested at 1 minute and what they would have texted. So who texts the most in that 1 minute? And of course we can see here that 50 words beats 45 and 40 words in 1 minute, and Michaela is the fastest texter. We're going to add another person, Max, and he can text 55 words a minute. Here's his table. I left it blank. I want you to fill it in. Just grab a piece of paper, draw it out, spend time figuring out what this would look like if Max can text at a rate of 55 words per minute. Now, depending on what values of minutes you used, your table may or may not look like this. But of course, at 1 minute, Max would have texted 55 words. And at 2 minutes, that would be double the amount of words, so we'd have 110. 3 minutes would be triple that amount of time and triple that ratio, which would be 165 words, and so on and so forth. All right, we're going to talk about some people that are making juice now, and they have grape juice concentrate. It's that can of frozen stuff that you may have seen someone buy from the store. But in order to make juice from it, you need to add water to it. Now, depending on how much water you add, that will change the strength of the flavor. Loreto, Franca, and Milton, they're the 3 people that are making this juice. They have different amounts of water and different amounts of juice concentrate. That's the JC, by the way. And then that last column in each table, total, is how much water and juice concentrate they used in all. And our question is, whose juice had the greatest water to juice concentrate ratio? So, whose juice would taste the strongest? Okay, who had the greatest water to juice concentrate ratio? What are we going to do here? Like the last problem, I'm going to look for a certain amount of water or a certain amount of juice concentrate that's the same in all 3 kids. But I don't see that again. But I do notice that Loreto and Franca have the same amount of water that they've used in one of their rows, and that's 15 units of water. When I look to the corresponding ratio or value of juice concentrate, I see that Loreto has 15 to 5 and Franca has 15 to 3. That means for every 15 units of water, Loreto would pour that into 5 things of juice concentrate, whereas Franca would only pour that 15 into 3 units of concentrate. So which has the greater water to juice concentrate? Well, that would be Franca, because she's using that same number of 15 and pouring it into 3 things of juice concentrate. That means there's more water for every one of those 3 juice concentrates. So now I know that Franca has a greater water to juice concentrate ratio than Loreto, but I don't know, Milton might have a greater one. So I'm going to look for Franca and Milton, any corresponding numbers and values, and look there at the bottom. Franca uses 40 units of water, and so does Milton. So this will help us. Franca uses 40 units of water for every 8 units of juice concentrate, whereas Milton uses 40 units of water for every 10 juice concentrate units. So again, Franca is pouring all of that 40 into 8, meaning that each of those 8 is going to have more water compared to Milton taking the 40 and pouring it into 10. That would be less amount of water. So it looks like Franca is the one that has the greatest water to juice concentrate out of all 3. By the way, what was the ratio that was used to create each of these tables? Well, depending on whatever values I want to choose from Laredo's, I see that Laredo has a 3-to-1 ratio. Let's take the first level of values. We have 12 water to 4 juice concentrate. Well, I can simplify that down, divide both by 3, and come up with 3-to-1. Franca will have a ratio of 5-to-1 because I can take the 15 water to 3 juice concentrate, simplify that to divide both by 3, and that would be 5-to-1. And Milton will have a 4-to-1 ratio, 4 units of water for every 1 juice concentrate, because look at the bottom, the 40 to 10 there on Milton's. If I take both the 40 and the 10 and divide them by 10, then I'll end up with 4 units of water for every 1 thing of juice concentrate. Well, now that I know all the ratios, that actually makes that earlier question simpler and allows us to put these 3 kids in order from whoever has the greatest water to juice ratio to the least. Here are the ratios again, and as you can see, like we talked about before, Franca has the greatest ratio, 5-to-1. So who has the next amount? Milton would have that 4-to-1, and the least amount of water to juice concentrate would be Laredo at 3-to-1. Okay, the next day, they're going to make apple juice, and they have a bunch of different values. I'm going to ask a similar question. Whose juice has the greatest water to juice concentrate ratio? And whose juice would taste the strongest? And wouldn't that mean the least water to juice concentrate ratio? Okay, I'm going to take Laredo's values over here, 12-to-2. And I'm just going to find out what his ratio is right off the bat. And if I record that off to the side, I know that the ratio 12-to-2 exists. Now, I also know that 12-to-2 is a value of 12 halves. And I know that 12 halves can simplify to 6. And I'm going to do the same for Franca. I'm going to grab some values here. I'm going to find out what the ratio is. 12-to-8. I'm going to simplify this ratio by turning it into a fractional value, 20/8. And then because both sides can be divided by 4, I simplify it and find that it's equal to 5 halves. And lastly, we have Milton. I'm going to grab a pair of values that I think I can simplify easily, 40 and 15. That looks like something I can deal with. I'm going to record it on the bottom as a ratio. Now I'm going to take this ratio of 40 units of water to 15 units of juice concentrate, turn it into a fractional value, which will be 40/15. And so I can divide the 40 by 5 and come up with 8, and the 15 by 5 and come up with 3. 8/3. And so here's all my data. Laredo's juice ratio is 6-to-1, Franca's is 5-to-2, and Milton's is 8-to-3 with their corresponding values here in fraction form. Now I can look at these fractions, and I can either divide them and turn them into decimals, or I can make them similar fractions with the same numerator or the same denominator by multiplying them equivalently, and I can compare them to see which child has the greatest water to apple juice ratio and whose apple juice would taste the strongest, having the least water and most apple juice concentrate ratio. So go ahead and do that. Find out who has the greatest water to juice ratio and who has the greatest juice to water ratio, and put them in order from strongest apple tasting to the weakest apple tasting. Alright, and this is what you should have come up with. The greatest juice tasting drink would have been Milton's, because his 8 things of water to 3 things of juice is equivalent to about less than 2.5 as a value. Franca's, if you have 5 things of water to every 2 things of juice, would have been the medium tasting one, because 5 to 2 in a fraction form would be 5 halves, and 5 halves is equivalent to 2.5. And then we look at Laredo's, who is 6 things of water for 1 juice concentrate. That's a fractional value of 6, and so that would have the most tasting water, and there they are. So I want you to take a minute and explain how the ratios helped us compare these juices. Also, take a minute to answer this question: how was this problem different than the grape juice problem? So wrapping it all up here, what have we learned by comparing ratios using ratio tables? Well, we've learned that ratio tables can be used to compare two or more ratios. We've also learned that in order to compare two or more ratios, we need to look for equal amounts in rows or columns so that we can compare the second amount to each other. Remember how we looked for same numbers like Laredo's 15 and Franca's 15, and we could look at them and see, oh, Laredo has more juice concentrate for every 15 than Franca did. And yet one other method we used was to compare the values of each ratio. So we would just take Laredo's and Franca's and Milton's ratios, turn them into fractional values, and then be able to look at those values of 6 and 2.5 and a little bit less than 2.5 and be able to order them that way. Lastly, we also learned that we can extend tables however far or however much more we need to. And by either multiplying the values or dividing them, making sure we have equivalent ratios, we can find or make for ourselves values that are the same for every table that we're comparing in order to then have ratios that we can look at and say, okay, this one is greater or less than.